All right, good morning. This is a free class / tutoring session. This was made for my algebra class, but I'm just going to put it out there for everybody. We're going to go over what slope means and then how to graph in algebra using your slope and your intercept. We're using the Spectrum 8th grade book. I'm going to show you the pages, so this is good for everybody. You don't need the book to go over this tutorial, but this is the book my class is using right now. And this year, this is the brand that I'm using. I might change that in the future. So if you do have the book, let me tell you what page I'm on. And we're starting on page 35. So 35, let's jump in. Okay, we previously had done a lesson on proportions and unit rates. And unit rates are really important when it comes to slope because we have a ratio, we have a consistent relationship with two factors. So on this one, we're looking at Michael mowing yards for 5 days. And there are two variables. We have the number of lawns, and then we have the money that he's earning, the total money that he's earning. So when he mows one lawn, he got $20. When he mowed 3 lawns, he got $60. When he mowed 6 lawns, he got $120. Are we starting to see a consistent relationship? You can tell that in his business, every lawn he mows, he earns $20, right? You look at this table, in each of these things, the bottom number divided by 20 is the top number, or the top number times 20 is a bottom number. So there's a consistent relationship. The ratio is 1 to 20, right? We talked about ratios. The unit rate is $20 per one lawn, which we would write as a fraction. We would just invert the values and go 20 over 1. $20 per one lawn is the unit rate. Now, when we get a consistent relationship, that will be the slope. It's also called the rate of change, right? Because it's a consistent rate and it's changing depending on how many lawns he mows. That's going to tell you how much money he's earning. So another word you're going to hear us start throwing around, which I haven't yet with my class, is that we have an independent variable and a dependent variable. So the top one, the number of lawns is independent because he gets to choose that. You know, he can be like, I'm going to mow 2 lawns today. I'm going to mow 5 lawns today. And then the money he earns depends on how many lawns he mows. So we have the independent variable and then the dependent variable. They're called a variable because they can change. They obviously change from day to day, right? He's building his business. He's getting bigger and bigger every day. It could go down as well, but it's always consistent. And we're going to show how we can take this information and put it into a graph. And then a graph is the same information, but instead of being represented on a table, it's going to be represented visually on a graph where you can see a line sloping down or sloping up, right? The more lawns he mows, the more money he earns. So it's going to slope upward and upward. That's why it's called a slope, because it's this diagonal line on a graph. Okay, so and this says the rate of change in this situation is 20, because every time you take a step forward, you go up 20. Every step forward on the graph is going to be the number of lawns he's mowing, or like one more lawn is another step forward, and that's another $20. So in that situation, it's pretty clear. It makes a lot of sense, hopefully. Okay, so let's look at this one. Students are buying tickets for the fall dance. The student council keeps track of how many tickets they sell in 1 week. If they have 10 tickets sold, they got $50. So what is your unit rate already? And I'm inverting it, right? I'm going for every, yeah, we want to invert it. For every $50, they had to sell 10 tickets, or for every $5 earned, they had to sell 1 ticket. So you can tell that tickets cost $5 each. And you can, I mean, these are consistent, but you can go ahead and check. 15 times 5 is 75, yes. And then you can use your calculator and double check these other ones. So what is the slope in this situation? Now you need to look at that rate of change because they only tell us values for 10, 15, 23. So then this is what you don't want to do. Don't fall into this trap of going, well, 50 to 75, that's a 25, that's 25 rate of change. But then this one, that's a lot more than 25. So it's inconsistent, right? Well, that's because I'm not looking at the unit rate. For the unit rate, I need to draw, I'm going to imagine an extra box here and say, if it was only one ticket, how much would it cost? $5. And then I have to make sure that's consistent. Is it a ratio of 1 to 5 each time? This is a 1 to 5 ratio because I can simplify that. 15 over 75 is a 1 to 5 ratio because I can simplify that. So the rate of change is 5. See how that works? Okay, Jean planted a sunflower. She decided to measure how much it grew each week. Now we're going to start at 1 and count. So this one is nice. It already gives us the unit rate, and hopefully it's consistent. 1, 2, 3, 4. Is it 16.2 each time? No, it's not. You notice this did not jump up 16.2. So that tells me that it already had some height when she started it. So on this one, since it's not consistent, well, hopefully, first, let's see if it's consistent between the 2 and the 3, the 3 and the 4. Okay, so I'm just going to take out my calculator and go 28.8, subtract 24.6. That was a change of 4.2. And then you can see with mental math, this other one is a change of 4.2. So it is consistent if you start, let's see, this is 4.2 as well. So we have to start at a certain number. Okay, so this one adds this extra trick. We're going to put in a 0 here. We need to find out where it was at when she first planted it. With 0 weeks, the moment she planted it, she must have been transplanting it, right? Because it already had some height. How much height do you think it already had? We need to keep that 4.2 and stay consistent. 16.2, take away 4.2 is 12. So it was already 12 centimeters when she planted it. Now that's really important. We need to know what that dependent variable was when her time was nothing, because this is going to be the y-intercept on our graph. So it started out at 12 centimeters. Now let's remember that as I erase it. The rate of change is 4.2 centimeters each day, but it was 12 at the beginning. So it started at 12 centimeters, and then after 1 day, now it's 16.2. You see, because we added the 4.2. On the second day, we added another 4.2, and now it's consistent. It goes 4.2 centimeters every day. That's pretty quick growth. All right, anything different on this page? Let's find out. I'm not sure. Eric walks to his friend's house. Determine if each slope or rate of change is consistent or variable. Okay, so this one's easy. We just need to know, is this a consistent rate of change or not? And remember, the first jump, no, okay, we're still looking at the difference between the numbers. The reason that last one, the reason we could tell that something was a little bit off, let me just go back to that. Was it consistent? We're adding 4.2 each time. Yes, that was consistent. The only trick there was it didn't start at 4.2. So this number was misleading. So we had to add in our extra 0 and 12, right? So we can still ask the question, is it consistent? It just might not be that first number, right? Well, in this case, it is. Because you can see it goes, it's a quarter increase each time. 0.25, 0.25, 0.25. So it started with 0.25, which tells me when the top was 0, the bottom was 0. We started out at the origin, the 0, 0. That's the origin. And then every time it went up 0.25 or a quarter, And so the rate of the rate of change is constant. You're just supposed to put the word constant. Okay, what about this one? Now I'm going to be quiet for a minute because I want you guys to think about this. You're going to look at that rate of change on the bottom. Is it consistent or constant, right? Those two words mean the same thing. Well, we have an increase of 0.5 and then an increase of 0.8 and then an increase of 0.2. So no, it's not constant. She rode her bike through town. She must be stopping to pet a dog or something like that, but she's not being consistent, right? So we would say variable, meaning it varies. It's not consistent, it varies. When it varies, you cannot graph that. Or if you do graph it, you'll be graphing like the average, right? We're looking for a consistent rate of change to be your slope on a graph. Okay, Johnson is ordering t-shirts for his school. The more he orders, the lower cost per shirt. So now the total cost is going up, of course, but then the price per shirt is going to change. So just that situation already should be raising a red flag in your mind, right? It just tells you already, the more he orders, the lower the cost per shirt is changing. Let's see if we can verify this. This was, okay, by the way, I need to jump in. These jumps will only make sense to judge if it's consistent. I better double check that last one. Did I make a mistake? No, I didn't, but sometimes I make a mistake, right? Okay, we need to make sure that the top is consistent in order to compare if the bottom is consistent, right? So see how these are in even steps, 100, 200, 300, 400, 500. And that last one was 5, 10, 15, 20. So we're counting by a certain number, it's in even steps. Okay, so once it's in even steps, then we look at the bottom number. Is the bottom numbers in even steps as well? See, this is plus 400, 300, 200, 100. You can tell that the item price per shirt is getting cheaper and cheaper because the batch price is taking smaller steps forward, if that makes sense. Okay, so that one is variable. Another way to look at that, by the way, is to look at the ratio. 1 to 5, 2 to 9. Nope, that's not the same ratio, but it's getting to be a closer ratio or a smaller ratio, right? 3 to 12. Now that's a 1 to 4 ratio. So we went from 1 to 5 to 1 to 4. So that is a closer ratio or a smaller ratio. 4/14, that's 1/7. That's 1/3. So you can see how the ratio is getting closer and closer. All right. Bike rental costs $10 per hour. On the top, are we consistent? 1, 2, 3, 4, 5. On the bottom, 10, 20, 30, 40, 50. It's a consistent ratio of 1 to 10. The ratio is 1 to 10 each time. If we simplify these as fractions, it would still be 1 to 10, 1 to 10, 1 to 10. So yes, that is consistent. We could graph that very easily. It would start at the origin being 0, 0, because it's 10 steps. Even from the 0, that's 10 steps, 10 steps, 10 steps. Every time we take 1 step forward on the graph, we're going to go 10 steps up. Miles a plane traveled while flying. So at 20 minutes, it had covered 180 miles. At 40 minutes, it had covered 360 miles. So there's 2 ways to look at this again. We can look at the steps here. Is it adding 180 each time? We can also look at the ratio. The ratio is 1/9. And at the end, it is still 1/9. So that is constant. It's not changing. It stays the same. And then did it start? Let's look at where the origin was for extra measure. If we take that 180, 180, 180 and go backwards, we started at 0 and 0. So on the top line, we're adding 20. On the bottom line, we're adding 180. So extra point here. What's the unit rate? Because here we keep having 20 steps. If we only took one step, that will tell us the unit rate. How do we know? Like, let's an extra line here. We want to know at 41 minutes. And let's look at the difference in that single minute to get the unit rate. What would the difference be? Well, we have to look at the normal rate is a 20 difference and 180 difference. So we need to simplify that fraction, 20 over 180. We need to simplify that to be 1 over what? So divide that by 20 to get the 1. 180 divided by 20 is 9. So the unit rate is 9 miles per minute. Remember, a unit rate means we go something per 1. That tells us the slope is going to be 9. 9 per 1. The rate of change is constant, and the slope is 1. Sorry, 9. Okay. Then we're going to learn how to graph that. We're going to take the information and put it in a graph. That's where we are now. So there is this standard form or the slope-intercept form of a formula, an equation. And if it's not in this form, we have to put it in this form. We're learning in our class how to change equations around, right? We always want to get the y by itself. Sorry, I'm sick. I'm sick, but schoolwork goes on. All right. We're going to have y by itself, y equals. Zoom is like, you are muted. Are you trying to talk? No, I'm not trying to talk. I'm trying to cough. Get this off my screen. Okay, y by itself. And then we're going to have something x, something in front of the x, and then something by itself with no variable. We want it in that form. Now, this is a magical formula because whatever is in front of the x is the slope. Whatever is by itself is the intercept. So look at this equation. Look over to the graph. The intercept is at 5. You see how the intercept is at 5? Intercept means when you come from 0, like that day we planted the sunflower plant, how tall was it the day we put it in the soil? On day 0, it was already, I forget, it was already like 12 centimeters tall, right? So the intercept means when I'm at 0 on my horizontal axis, that's the x-axis. What am I starting at? My starting value is 5. And then every time I take a step forward, I go down 2. Why am I going down? Because the slope is negative. The slope is negative 2, so that means I'm going down 2 and then down 2. And it will continue. That line will go, it will extend forever in both directions. I can even plug a negative value in for x, and I'll get a higher and higher value for y. The further x goes negative, the higher and higher my y is going to be. So that's kind of interesting. But then the more days I go forward, now I'm getting a negative y. My answer will be more and more negative. So you can, let's go ahead and do that. Let's take a rabbit trail, we might as well. Let's experiment and see. So remember, this is my x. My horizontal is my x. My vertical is my y. So where's 3 going to be? It's going to be down here, right? I can tell it's like 2 steps down every time. So if my x is 3, my y should land here at -1. Is that true? Let's plug it in. We go to the x, we put in 3, that'll be a -6, because it's -2 times 3. -6 plus 5, yes, that will equal -1, so then the y is -1. So this is how that graph works. When you have 2 variables, x and y, there's no one answer. There's infinite number of answers. It just depends, right? You have a dependent variable and independent. So in this case, that y is the dependent variable. What does y equal? Well, it depends. What did you plug in for x? So your first step is to plug something in for x and then you see what y equals. So let's do a -1 for x. Let's say we have, we don't even know what this graph represents, right? But if we have a -1, where's my y going to be? Where would you expect it to be looking at the graph? Noticing that consistent pattern on the slope, where would you expect it to be if I'm doing -1? Where is that going to line up? I'm going to like go up, 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 up. I can't draw a straight line, but where, that looks ridiculous. But where would it end up? Okay, take your guess. Now let's plug in a -x, a -1 for x. So this would be -2 times -1. And that gives us a 2. And then 2 plus 5 equals 7 for y. 7 for y, was that what you guessed? Because it's right there on the line. That's the purpose of your line. Now I don't have to do all the math of plugging numbers in. I can just look at my line and see. Once you have a graph, it's like your answer key. It's your cheat sheet. Now you know all the answers are. All right, let's talk about a fraction slope. Using the slope-intercept form of an equation, draw the lines on the grids below. So we always start with the intercept. So it's going to be tempting for you to read left to right, but we have to do the intercept first because that tells us our starting point. Before we've taken any steps right or left, where did we start at? If x is just 0, where's that number? And by the way, you can see if x is 0, it'll cancel out that entire term. Anything times 0 is 0, so it's just going to cancel it out. You're going to be left with y equals 1. So that tells us when x is 0, y is 1. So we're going to start right there. Now, every time we take a step, we're going to go up 1/4. So it's going to take us 4 steps to go up 1, right? Because we went up a 4th, if I can draw that. Another 4th, which would be now halfway. Another 4th, which would be 3/4. Now you can see how I have formed a line. Do I know how to draw a line using these tools? I'm not sure how to draw a straight line using these tools. So it's going to be a really crude slopey line. And then another 1/4 and another 1/4 until it takes me 4 more steps to make another 1 vertical leap. So here's how I've been explaining slope so far. There's 2 ways to understand slope. Find the way that you like and just stick with it, right? I like to explain things in different ways. So every time you take a step forward, here's a step, here's a step, here's a step. Here. Every time you take a step forward, this is how much more vertical gain you make. 1/4. Every time I take a step forward, I go up 1/4. That's how I like to understand it. But when it comes to fractions, it can be really helpful. Whoops. It can be really helpful to understand the fraction as rise over run. Rise over run. Then you just plug the fraction in for that. So rise means you're vertical, run means you're horizontal. Rise over run, and I had a 1/4. That means every time I rise 1, I'm going to run 4. It's a ratio, remember? A slope means you have a consistent ratio. So the unit rate might be a 1/4, but then the ratio 1/4 means I go up, let's change my color. I go up 1 and then over 4. So you can draw a staircase, right? Up 1, over 4. And I can just keep going up 1, over 4, which is going to land me on 12 on the x, right? Up 1, over 4, up 1, over 4. So when the slope is a fraction, I like to think of it as rise over run. But you find what way works for you, which way makes sense in your brain, and just keep doing whatever makes sense. Okay, let's go to 1b. Y equals -x plus 2. I'm going to give you a minute to think about this. You start by taking that 2 and plotting it on the intercept. Where is 2 on the y-intercept with x being 0? Plot that point. Plot it in your mind because you probably don't have this in front of you. Or if you have your book, you're working on your book. All right, so it's right there. Now, y equals negative x. What does that mean, negative? There's no number there. But then the number that's implied is a 1. Whenever you just have a regular x or a negative x, that means 1 or negative 1. So when the slope is negative, every time I take a step forward, I'm going down instead of up. And if you think about the rise over run, the rise over run would be a negative 1 over 1, right? Can you see how when I just say negative x, the invisible part that is hiding is a negative 1? And then you make it a fraction, negative 1 over 1. So that means I'm going to rise negative 1, which means I'm going to fall, not rise. So we go down 1 and then over 1. And we land at 1, 1. Down 1 over 1, and we land at 2, 0. You could even plug in a negative number, and you'll get a negative 1, 3. A negative 2, 4. And you see how that forms a line, and it just keeps going forever, because you can keep plugging in whatever number you want. I could plug in a negative 100, and I would get a positive 102. You see how that works? All right, here's one where we want to do rise over run, 4 over 3. But before we do that, we need to plot the intercept. So you go ahead and try this one on your own. Plot a 4 on the intercept. And then you're going to do rise 4, run 3, rise 4, run 3. I'm giving you a minute to think about it. Draw your graph. Pause this video if you're still working. I'm going to put the answer on. Okay, we start at 4. And then we rise 4. That'll bring us to 8. And we run 3. That'll bring us to 3 on the x. So that's our next point. And I ran out of room on my graph already. But I'm going to be up to 12, right up here on the 12. But then I have to run 3. So that'll bring me over to the 6. So 12, 6 is my second point over here. If my graph were extended. Okay, see how that works? That's what your graph looks like. So I hope that's what you drew. Good job if you got that. And if not, we'll just keep trying. We'll keep practicing. Okay, our last one. We have a y-intercept of 3 and then a slope of 2. Every time you move over once, we're going to go up 2. There's our y-intercept on 3. Sorry, pause the video if you haven't yet. Finish it yourself. Okay, we're going to go over 1 and up 2. Over 1 and up 2. Over 1 and up 2. And then we connect the dots to form a line. Arrows on both sides because it goes on forever. All right, that's an arrow, I promise. There's your answer. All right, now they're giving us a picture and we have to write the equation. Remember the first part. So I'm going to think y equals something x plus something. What's the plus something? The intercept. Where does intercept on the y-axis? At 7. So that number is going to be a 7. And then what's the slope? Can you tell by looking at it when it's nice and clean and it's forming all these cute triangles at a 45-degree angle? Then you know the slope is either 1 or, in this case, negative 1 because it's going down. So that's a negative 1, or we could just put negative. Negative x plus 7. Okay, take a look at 1B. Come up with your own answer there. Now remember, don't get confused. You can see a difference of 2 there. But you got to think every time I take a step forward, I'm only going up a half. Or I think rise over run. Yes, it's a difference of 2, but I only rose 1 and then I ran 2. So it's 1 over 2. Another rule of thumb is that when it's a gentle slope, it's going to be a fraction. See how this is a more gentle slope? Like that's a doable hike. But if I was hiking up in this direction, that would not be a doable hike, right? That's a harsh slope. Or I mean, this one would be your neutral slope, or your normal slope. And then if it's more gentle than that, it's a negative. If it's more steep than that, it's a big number. Like this is a slope of 5. See that? Oh, that looks horrible. Okay. So that's a slope of a half. The intercept is 4. What's the equation for that? Y equals, the slope is a half, so it's a half x plus 4. Oh, and you can't really see that anyway. Okay, let's go down. 2A and 2B. What's my intercept on 2A? We're intercepting at 6. So it's going to be plus 6. And then what is it going to be in front of the x for the x term? Now this one's more difficult. We got to take a closer look. Let's think rise over run. Well, it's negative, right? How much did we go down? We went from 6 down to 0. On the vertical, 6 down to 0. How much did we run? 4. So now we have a fraction, and we want to simplify that fraction. Keep it as improper fraction, but what is it simplified? -3/2. So then my equation is going to say y equals, okay, what's the slope? -3/2 x plus 6. Okay, 2b, what's the intercept? Well, it starts at the origin, so that's easy, just 0, 0. So your intercept, that part of the equation will say plus 0, but we don't need to write that when it's plus 0 because that means nothing. So it's not going to have anything plus. It's just going to be y equals something x because it will cancel out. I mean, it will just be 0. So what's the x value? Let's do the rise over run. Now, we need to find a point where it crosses. Do you see right here? It's touching. It crosses exactly on the lines. And is that consistent? Every 3 steps, does it cross again? Just to make sure. Yep, that's consistent. Okay, so we go rise 2 over 3. Rise 2 over 3. Rise 2 over 3. So what's the slope? 2/3. We'd make it into a fraction. Remember, rise over run, that makes a fraction, 2/3. So our equation is going to say y equals 2/3 x, and then we don't have anything for the intercept. So it's just y equals 2/3 x. And again, we can plug in numbers and just double check. Let's plug in this 6 right here. Let's plug in the 6, and we should be getting that 4 for the y. So remember, we have an independent variable that we can choose whatever number we want, and then the dependent variable, the y, just depends on what you plug in for the x. So if I put that 6 in, I have 6 over 1 times 2/3, right? Because it's 2/3 x, I plugged in the 6, so it's 2/3 times 6, and I'm allowed to switch that around, 6 times 2/3. I cross cancel, I get a 1 and a 2. 2 times 2 is 4. Yes, I got a 6 and then a 4 for the y. All right, last page, stick with me. Here they give you the, without looking at a graph, they just tell you the slope and they tell you the intercept. So you are going to go ahead and I want you to write down the equations. Y equals something x, that's the slope, plus the intercept. You go ahead and do this, and I'm going to show you the answers when you're done. Okay, pause this video now until you finish all 9 of them. Okay, ready for the answers? If you finished all 9 of them, we're going to check your answers right here. Go ahead and check. If you got them right, congratulations, you understand. I hope this helped. I hope I explained this well enough. You can rewatch this video again. If you're in my class, we'll be going forward and using this more. If you did not get the right answers, call me up for a tutoring session and let's go over it more, where I can follow your lead and find out what is getting difficult for you. Okay, so there you go. That's your finding slope, finding intercept, graphing, and knowing how those slope intercept equations work. So thanks for joining me.